Okay, hi guys, I apologize that I'm not here today, but I do have notes for you. So please take out a sheet of paper, and if at any point I'm going too fast, feel free to pause it, and then you can hit play when you're ready. We are on day 2, section 5.2, exterior angles. I also want to apologize that my handwriting on this app is not great. Okay, before I can talk you through our 2 new theorems, I need to talk about what an exterior angle is of a triangle. So draw yourself a triangle, and then on that third side, extend it out past the triangle. And we have just created our very first exterior angle. An exterior angle of a triangle is formed whenever a side of a triangle is extended to form an angle that is supplementary to the adjacent interior angle. And so here's that vocab word right here. This is the adjacent interior angle. And then the remaining 2 angles are still interior angles, but they have the word remote put in front of them. Remote interior angles, and that's very important. Remote interior angles. Now this portion you do not need to write, just pay attention. We'll write this up officially, but let's just try to develop the idea a little bit. I'm going to redraw that picture. Like I said, do not feel like you have to do this. And I'm just going to go ahead and put in some values here. If this adjacent interior angle was, let's say, 30, what's left for the exterior angle is its supplement of 150. Well, what also is left for the 2 remote interior angles? Well, to make a triangle, we know that a triangle has to add up to 180. And 180 subtract that 30 that we already have means that those 2 remote interior angles have to add up to 150. Well, this develops our 2 ideas for the day. First one, and I'll write this all up nice and fancy, so just pay attention, is that our exterior angle of a triangle will always be greater than either one of its remote interior angles, because if you look at that, you know, those 2 remote interior angles together are making 150, which is the same as our exterior angle. And our other theorem for the day is that actually our exterior angle of a triangle is equal to the sum of the 2 remote interior angles. So that is our ideas for the day. So let me write those up nice and official like, and we'll do some examples of those. Okay, so our first theorem for the day is our exterior angle inequality theorem. Exterior angle inequality theorem. And this is what we just discussed, but it says the measure of an exterior angle of a triangle is greater than the measure of either remote interior angle. The measure of an exterior angle of a triangle is greater than the measure of either remote interior angle. Quick picture-wise, if you want to draw that, if I label these A, B, C, and D, all this is stating is that D is greater than B and D is greater than A. Once again, if I am going too fast, please pause it. Okay, so now we're going to try some examples of the exterior angle inequality theorem. Number 1. Directions are to complete the inequality. Give you a picture with an exterior angle of 120 and a remote interior angle of x, and then I'm going to give you an inequality to fill in. This is called a compound inequality. You hopefully learned this in Algebra 1. X must be greater than a number and less than a number. Well, let's use our exterior angle inequality theorem, which states 120 is our exterior angle is greater than our remote interior angle of x. Now, I don't know about you, I struggle to read that. I like to have my x first. Therefore, this is really saying x is less than 120. Therefore, I can go ahead and start to fill in my inequality. Well, x has to be less than 120, but x also has to be greater than a number. Well, this one's not too bad. In order to make this a triangle, is it okay for me to have a negative angle? Well, hopefully you're saying no. And it's not okay for me to have a 0-degree angle. Therefore, we know that x, in order to make this a triangle, has to be greater than 0. And that is our official answer. 0 is less than x, which is less than 120. So x is sandwiched between 0 and 120. Okay, number 2. Write a valid inequality and find the restrictions on x. So very similar. I'm still going to have something where x is greater than a number and x is less than a number. Okay, so in this case, my exterior angle is 4x minus 5, and I know one remote interior angle is 35. So we might as well use our exterior angle inequality theorem for those two. 4x minus 5 must be greater than 35. Add our 5 to both sides, and 4x is greater than 40, resulting in x is greater than 10. Well, I might as well set up that inequality much like we did on the last one. And I'm going to have x is greater than a number and less than a number. Well, looking at that, x is greater than 10, so I can put my 10 in. Well, now we got to find what x must be less than. It's not going to just grow without bound. Well, let's think about this. In order to make this a triangle, we need to make sure that that 4x minus 5 is less than 180. Giving us 4x is less than 185 divided by 4, and we get 185 over 4. And just try to make sense of that. That angle that is adjacent to 4x minus 5 has to be greater than 0, or else it is not a triangle. It could be very small, but it has to be greater than 0, which is why 4x minus 5 must be less than 180. You're welcome to go ahead and find the decimal equivalent. I'm going to just keep it as 185 over 4. And I have done my problem. Okay, move into our next one. Number 3. Draw you a nice picture. Okay, so we've got a bunch of angles to talk about, 1 through 10. Okay, I've got 3 questions on this diagram, for this diagram. First one. What is the exterior angle to triangle ABE? Looking at triangle ABE, what angle is its exterior angle? Hopefully you are saying angle number 7. Not too bad. Next one, which angle is larger? Angle 4 or angle 8? Which is larger, 4 or 8? I need to do some highlighting for this. Let's see, 4 and 8. Makes me think I need this triangle. Well, by doing that, I hopefully you realize that 4 is the exterior angle of that triangle. Therefore, angle 4 is larger than 8. And finally, which angle, once again, is larger? Angle 1 or angle 3? Which is larger, angle 1 or angle 3? I'm going to highlight. And notice that angle 3 is the exterior angle of that triangle. It is larger than its remote interior angle of 1. Okay, our last theorem that we talked about is our exterior angle theorem. And just like we discussed at the beginning, the measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. And I'll write that. The measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. Okay, if you need a quick picture of this, A, B, C, D. All this is stating is that D equals A plus B. Okay, last example. Find the value of x and angle F and U. Okay, angle F is x plus 50. Our exterior angle is 2x plus 50. And angle U is 40. Well, it said the measure of our exterior angle is equal to the sum of the measures of the remote interior angles. Therefore, we can set up 40 plus x plus 50, that's my remote interior angles, are equal to 2x plus 50. And now we just work our algebra. X plus 90 equals 2x plus 50. Subtract x from both sides, we get 90 equals x plus 50. Subtract our 50. And x equals 40. Well, I've answered what x is, but now I've got to find f and u. I'm going to just redraw it, and at the same time plug in my value of 40. We have our 40-degree angle. X plus 50 turns into 90. And 2 times 40 is 80, plus 50 is 130. Okay, that tells me I did it correctly. 90 and 40 is 130. Now we've got two options here. We can either say a triangle has to add up to 180, Or we can say that the exterior angle is the supplement of our interior angle. I'm just going to do that. Angle FNU will be 180 minus 130. And we end up with FNU equaling 50 degrees. Okay, once again, I apologize for not being here today. My solutions will be online. Feel free to email me if you have any questions, and we'll have plenty of time on Monday to go through questions. Have a great weekend. Bye.